Okay, we're going to start talking about chapter 2 today, which is all about representing data in tables and graphs and charts. So in section 2.1, we're going to talk about organizing qualitative data. And remember, qualitative data is also called, that's awfully big, called categorical data. And remember, that's names, labels, that kind of data. So, filling in here, qualitative or categorical data provide measures that categorize or classify an individual. When raw qualitative data are collected, we often first determine the number of individuals within each category. Once we've done that, we can make a frequency distribution. And a frequency distribution lists each category of data and the number of occurrences for each category, meaning the number of people in that group. In any frequency distribution, it's a good idea to add up the frequency column to make sure it equals the total number of observations. And often we want to know the relative frequency of the categories. Now, relative frequency is really the same as the probability of randomly picking one person and having them be in that category. So this is where all that chapter 5 material comes back to us, even in the statistics part of the class. So the relative frequency is the proportion, which is a decimal, or we can change it into a percent of observations within a category. And the formula for that is the number of, the number of observations in the category divided by the total number of observations. So a relative frequency distribution lists each category of data together with the relative frequency for each category. All the relative frequencies should always add up to 1. This is very important that they always add up to 1. If they don't, then we have a problem. So let's look at an example on the next page. We have a physical therapist who wanted to determine the types of rehab required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records the body part requiring rehab. So construct a frequency distribution of the location of the injury. So you can see here we have a table of body parts, and below that we have a table that has each body part listed, and then a column for frequency and a column for relative frequency. So let's start with back. We just count the numbers, and I'm going to cross them off as we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 back patients. If we do the same, we'll find we have 2 hands, 2 wrist patients, 1 groin, 1 elbow, 4 shoulders, 2 hips, 5 knees, and 1 neck. So let's check the total and make sure it adds up to be 30. So stick all this in the calculator. 12, 14, 16, 17, 18. Plus 4 is 22. Plus 2 is 24. Plus 5 is 29. Plus 1 is 30. So that's good because we had 30 observations and we have 30 total in our frequency. That means we didn't miscount anything. Now, to find the relative frequency, we take the number in that category. So we have 12 back patients, and we divide it by the total number of patients, which is 30. And then we generally round that, well, we make it a decimal. So we have 0.4 for that one. Continuing, 2 over 30 is 0.0667. We have 2 over 30 again, which is 0.0667. 1 over 30 is 0.0333. Another 1 over 30 is the same. 4 over 30 is 0.1333. Then we have another 2 over 30. And I'm just getting these by putting 2 divide 30 in the calculator. 5 divided by 30 is 0.1667. And the last one's 1 over 30 is 0.0333. Now remember, if we add all the relative frequencies up, we should get 1. If we add them up as fractions, we should get 30 over 30. And if we add it up as decimals, we should still get 1. Which we will if we do that. I'm going to end this video here, and we'll pick up in the next video with bar graphs.